Hello y'all, and welcome to the channel. Today we're going to be solving Leetcode problem 974, the subarray sums divisible by k. So in this problem, we're going to be given an integer array nums and an integer k. And what we're supposed to do is we're going to return the number of those non-empty subarrays in that integer array nums that are divisible by k. And a subarray is going to be a contiguous part of the array. So for this problem, there's one straightforward idea that could come to mind, and it's just a brute force approach to this method. So in theory, if you figured out and looked at every single subarray that is possible, you would get the answer, right? So if you perhaps looked at this portion of the array and you started there, right? And then you looked at the next subarray, right? The sum is 9. This sum is still 9. This sum is 7. This sum is 4. And then this sum is going to be 5. So because this is the only number that's divisible by 5 in our results, it initially starts at 0, we can increment this by 1. And then we're going to continuously do that for every single possible subarray that we can. So we'll start at this number next, which is the next index, and then continue to do that until the very end and find all those possible subarrays that we can, right? This is definitely a method that we could implement, but as you can see, there's a lot of revisiting sections that perhaps we don't need to revisit. So there's another possible method that we can do, and it involves the running sum method. And I'm going to show you exactly what that entails, okay? So if we have the running sums for all of these values, so this arrow right here represents the sum from this number all the way to this number. All right, so we'll start from the left side. So this running sum is going to be 4, right? The next running sum is going to be 9. The next one is going to be 9 again. Then we're going to get to 7, then 4, and then 5. All right, so if we're looking at this, right, we can see that if we use the mod function, or if we just divide each of these numbers by the k value and find what that remainder is. So if we do 4 mod 5, we're going to have a remainder of 4, right? So this remainder is going to be 4. Let me just change this color so it's easier. So remainder of 4, right? This one's going to have a remainder of 4 as well. Remainder of 4. Remainder of 2. Remainder of 4. And remainder of 0. But we're also going to include a remainder of 0 initially, because our running sum at the start is going to be 0, right? So what we could do for this is, let's say we had our we're going to want to see how many subarrays are divisible by 5, right? So if we just look at this, if we start at this value, we're going to check how many values before that have the same remainder. There's no values before that that have the same remainder, right? And you could see right here that there's no possible way in this value right here to be divisible by 5, right? The subarray this way. So if we go to that next value, which is at this location, which is at 5, right? Then we can see that there is a remainder, right? So we can see that there is one possible solution. And if we go look at this subarray right here, the subarray that we're looking at would be this one, because 5 divided by 5 is equal to 0. Right? There's no remainder there. So initially for this one, we have 0. We have 1 subarray at the index 1 for this section here. And if we go to the next subarray, if we're looking at this one, you can see that there are 2 remainder 4s compared to this remainder 4, right? So then we can increment that to 2. And if we're looking at this section, the subarrays that are possible, right? Oh, let me write a 2 there, are this one, or sorry, this one, or this one, which was the 0, right? So we can continue doing that. So we can see that there is no remainder 2 below that. For remainder 4, right, there are 3. So we can have 3 under here. And then for 0, there's only 1 remainder 0. So we're going to have a 1 value here. And if we sum up all these values that we have over here, we are going to get a result of 7. And as you can see, the answer for this section is 7, right? So that's how we're going to go about this problem. And let me go over one more example if y'all need to understand what we're going to be trying to do in the code. So initially, we're going to have a caching system, right? And the caching system is going to work like this. So the key is going to be the remainder. And the value for that key is going to be the number of values that have that remainder. All right, so we got that all covered. Here we go, and I'll put that right here for y'all. Okay, and we're also going to want a running sum value. So the running sum that's going to be initialized at 0, right? And then we're also going to have a result. And that's going to be initialized at 0 as well. Okay, and then since we're going to be looping through each of these numbers, for each of the loops, what we're going to want to do is we're going to find this key or that remainder for the running sum, right? So we're going to have a key variable, and this is going to be calculated every time. So for every number, that's going to be calculated. And yeah, so also in our cache, we're going to also initialize a key value pair of 0 to 1. Because if our remainder is ever 0, that is already a subarray that is divisible by k on its own. Because like if we started at another value such as 5, right, or 10, since it's divisible by 5, we're going to want to see whether or not that's already in our cache system. And it is, so we'd increment our result by 1. So let's start with this problem, right? So we are going to start at the very beginning of the index, which is going to be 4. So right now, our running sum is now going to be incremented by 4. And our key is going to be 4 mod 5. And 4 mod 5 is going to be equal to 4, right? So our running sum again is 4, and our key is 4. So we're going to look to see if this new key is in our caching system. And it's not in our caching system, so we're going to add our new key to our new value, right? So then we're going to go to the next value, which is 5, right? And remember, we're going to recalculate this key. So now the running sum is going to be 4 plus 5, which is going to be equal to 9. So now if we do 9 mod 5, it's going to be 4 again, right? And now we're going to check to see if this key value is in our cache system. And we can see that it is in our cache system. So now because of that, we're going to take the value from our caching system and we're going to add that to our result. So now our result is going to be 0 plus 1, which is now going to be 1, right? So now, here it is. So now our result is 1. Now we can go, actually now since we saw that it was already in our caching system, we have to increment this value by 1. So we're going to add 1 to it and we're going to get 2. All right, so now we're going to empty our key because we're going to go to the next number. Now it's 0. So our running sum is still going to be 9 because if we add 0, it's going to be 9. And our key is going to be 9 mod 5, which is equal to 4. And we're going to see if our key is in our cache, and we can see that it is. So we're going to take this 2 and add it to the result, right? So 1 plus 2 is equal to 3. So now there's 3 subarrays so far in this part of the portion of the array that we're looking at. And now, after we added to the result, now what we're going to do is we're going to add 1 to this portion of the caching system. And now, since we're going to go to the next value, we're going to change this num to -2. So 9 plus -2, that is going to be equal to 7. And 7 mod 5 is equal to 2. We're going to have a remainder of 2. So we're going to check to see if that key is in here. And it isn't. So what we're going to want to do is we're going to add 2 to the caching system. And we're going to initialize it at 1. And because initially this was technically 0, we're not going to add 0 to result. We could, but it does nothing. All right, so now we're good on that. And now we're going to go to the next value in our nums. And our key is wiped out. So now we're going to add that -3 to our running sum. And that's going to equal to 4. So now 4 mod 5 is going to be equal to 4. So now we're going to check to see if 4 is in our cache, and it is, as you can see right here. So we're going to add 3 to result, and that's going to give us a value of 6. All right, and now we have to increment our cache by 1. So now it's 4, 4, and our key is going to be wiped out because we're going to go to that next value in nums. So now we're going to add 1 to our running sum, and we're going to get a value of 5. So 5 mod 5 is equal to 0 because we have a remainder of 0 for that. And we're going to check to see whether or not that value is in our cache. And we can see that it is right here. So we're going to add this value to result. So now it's going to be 7. And we're going to increment 1 by 1. And now it's going to be 0, 2. And now, since we finished going through this array, we did everything that we needed to. We reached the end. So now all we're going to do is return this result that we got here. And as you can see, and we looked at earlier, the result 7 is the answer for this section. And now we'll be going to the coding portion so y'all can see how that's going to work. All right, so now we're at the coding portion, and remember in our drawings, what we want to have as constants at the beginning of this problem are we're going to want our result and we're going to want our running sum. And those are both going to start at 0, so we can just make them both equal to 0 like that. And we're also going to want our caching system. So our cache system is going to be a dictionary. And remember, we're going to initialize that remainder of 0 to 1. So remember, the key is the remainder. And the value is going to be the count of that remainder. So now what we're going to do is we're going to iterate through each num. So for num in nums, right? And what we're going to do first is we're going to want to increment our running sum by the num that we're at, like what we did before. And after that, we're going to figure out what our new key or our key value is going to be. So the key is going to be the running sum mod k, right? Because remember, k is the value that we're trying to divide by. And now we're going to determine and see whether or not that's in cache. But first, what we're going to do is we're going to increment result by cache of the key. But guess what? We can only increment it by that if key is in the cache, right? If it's not, we're just going to increment it by 0, which is nothing, and result's going to stay the same. We also have to update our cache after we finish this section. So the key, or the cache of key, is going to be equal to 1 plus the cache dot get key, and if key is not in cache, we're going to just keep that at 0. And actually, if we just return result after this, if we submit this portion of the question, this is actually the solution for it, as you can see. So overall, this problem isn't actually too complicated. It's very simple, but to really understand the method, which I hope y'all do now, it should make future problems that are like this a bit simpler. If there's any other questions y'all have, please post them in the comments, and hope y'all have a great rest of your day.